profile is a description of how a river changes over its length. When we're looking at the stream profile, it's really important for us to note what features are located in the area, so that if we're doing a restoration project or recreating a channel nearby, we know what kind of bed features that we need to recreate and that diversity of bed features that you'd find naturally. Studies have shown that most of the streams in our region have been historically straightened. So when we're working on streams, it's important to understand the historic or natural sinuosity of the stream so we can try to get it back to that natural state where it would be more stable. Profile observation should be done outside the influence of any structures or something that's abnormally affecting the bed. You could imagine upstream of a culvert, sediment might be stuck, or upstream of a dam, it might be holding up sediment or water. So when you're looking at your profile, you really want to be looking at the natural condition of the stream. A healthy stream has periodic features that change along the length, but repeat over time. So those are called bed forms. And bed forms can take different forms depending on the type of channel, the type of sediment, and the slope. One of the common series of bed forms is a riffle pool series. The repeating bed features serve a couple of different purposes. One is to really control the slope of the stream and provide good equilibrium along the stream length. Having a large diversity of bed features is really important, not only for stream stability, but also for habitat. The type of habitat across these features is really different. In a riffle, you might have faster moving water and clean, larger stones that could provide a location for invertebrates to live, versus in a pool, you might have fish species being able to find shelter in the deeper, cooler water, as well as a location for them to rest and be able to feed. A riffle is the area of the stream where the water is moving fast. You can see that there's white water moving quickly down between rocks. Let's look at how deep the water is. Less than half of a foot here. You can also start to see what types of materials the river's made of here. We have large boulders. We have cobble-sized stones. So as we move further upstream, we can see that the water's changing. So we're moving into a different bed feature here above the riffle, where the water's gliding down and it's starting into the riffle here. So we call this a glide. We're now in a pool. So in a river, a pool is typically the deepest spot with the lowest velocities. You can see here that the water surface is almost flat and very, very calm. As you get into the pool, you actually have much smaller sediment, more of a sand. So the reason for the difference is based on the slope as well as the velocity of those different locations in the stream. So the larger substrate on the riffle is because the faster moving water has washed away those smaller particles, whereas in the pool, because you have a much lower velocity, those smaller sediments are able to settle out and settle into the bottom of the pool. So in addition to smaller sediment, you might find sticks and leaves and other items which provide great food for fish and other aquatic species. It's important to look at any kind of depositional or erosional features that you're seeing along the length. One of the most common depositional features are channel bars. Bars are locations of the channel, typically at the edges, where you have exposed substrate. So that means that they're dry locations of riverbed material that have accumulated or deposited along the river. They're usually named by their location. Common type is a lateral bar. That means that sediment has accumulated along the side of the river. These are really common on river bends, on the inside of a river bend, where the fastest moving water moves around the outside of the bend, depositing sediment on the inside of the bend. So that's called a meander bar or a point bar. Sometimes see a mid-channel bar, and these are created by obstructions such as large woody debris or upstream of culverts where the culvert has been slowing down water and depositing sediment upstream. When you're walking down a stream, it's often easiest to see when there's bank erosion going on. So on the sides of the channels, locations where you have raw exposed bank or dirt along the edges, you might see cracks in the banks or locations where the banks are actually falling in. Those are indications of an unstable channel that might be trying to move along its path. Another erosional feature is when the channel bed itself is eroding. So if you're walking up a channel and see an exposed face or a very steep drop, sometimes that's an erosional feature called a head cut, which is going to continue to erode upstream as more and more of the channel bed is eroded away. And that's actually causing incision in the entire riverbed to erode down. Sometimes things like this happen if a culvert washes out or a culvert is replaced and the bed is left abnormally steep. You might see that erosion face move upstream. Healthy streams have wood along their length, and all of that wood creates a lot of locations for habitat, creates stability. It can create scour locations with small pools where faster moving water has carved away a pool to create sheltered locations. Along with logs, you might also see accumulations of coarse organic particulate matter, which provides food for different species. One of the main variables that we use to describe the channel profile is the slope. So channel slope is a measurement or a calculation of how steeply the channel drops over a distance. So we calculate this with the change in elevation over the change in distance along the stream. Slope can be used as a surrogate for stream power, which is the flow times the slope. So there's a few different ways to measure slope. So in this case, we just measured using a hand level and rods and a tape, and did a second check using a rangefinder that has the ability to measure vertical measurements as well. Where you do the measurement in the channel is really important. You typically use a location on two riffles. Riffles are the features that really control the slope of the stream. If you would choose a riffle in a pool, you might wind up abnormally measuring a steeper slope than the channel really has. It's also important to choose a location that's not influenced by any structures or infrastructure or maybe a bedrock vein that might be kind of abnormally changing the slope locally. Important to understand the context of slope, both at a project location, a reference location, and within a much larger reach that might be over a mile in length. Often before I go in the field, I'll take a measurement using LiDAR or mapping to understand the larger context of the slope upstream and downstream of the location, and then get an understanding at the site of the local slope, either at a project location right local to a culvert or bridge, or the reference stream location. Riffle pool stream might have a slope of 1 to 2%, which means that the channel drops 1 to 2 feet over 100 feet. A steeper channel, 3, 4, or larger than that percentage, might be a step pool stream, and much lower slopes might be a dune riffle type of stream. What is our channel doing along its length? What kind of curvature is there? So we look at the plan form, which is looking at the channel from above in a plan view or bird's eye view, and how it changes along its length. One measurement that we look at is the sinuosity of the stream. So the sinuosity looks at how curvy or how many meanders the stream has along its length. This is a measurement of the channel length. So if you walk along the deepest part of the channel all along its length, divided by the valley length, which is often more of a straight length along its valley. So you divide that channel length by the valley length. If you have a sinuosity of 1, you have a very straight channel with very little curves. If you have a sinuosity of 1.5 or above, that's considered to be a meandering or pretty curvy stream. The interplay between the slope, the plan form, and the bed forms are really important, because if any of those features are out of equilibrium, or out of its natural state, you'll see a stream that's trying to get back to what it wants to be naturally. Those are the locations where you might be at risk for the stream moving or eroding into a new location as it tries to regain that equilibrium. You wouldn't want to ever change the sinuosity of a healthy stream in equilibrium, because if you straighten a stream channel, what you're doing is your stream still has to drop the same amount of elevation, but now in a shorter period, so you're steepening the slope of the stream. By straightening and steepening, you're also increasing the velocity, possibly beyond what the stream can really handle. Understanding the profile and the interplay between the different features of the sinuosity, the plan form, the slope, and the bed features is critical for making the right decisions when we're designing and making changes to our infrastructure or design projects anywhere around a river.